This is good. For a teacher to do something wrong, then you learn from his mistakes and you don't do it. Okay, so I should do it a little bit more maybe this way. Add a little piece here. So eventually I want to do it so that, let's go a little more here. Go 1 hour, go 1 hour, and then go a little shorter here. You see why that was wrong? A average total was ending up, so this one is going to be really short. This one is going to be probably a little bit longer. So then 1 hour. Let's now try it. And you can have one of those like little rulers for the test, and then you could do a little, you know, you can make the units symmetrical. Practice that, you know, so that your drawings are nice. Okay, so now connecting this and this, that's A average 1. This is 1 hour. This is the average 2. And perhaps the negative 180, I could have gone down a little more too, you know. 70, 70, 70. Yeah, I could have gone down a little more here. But anyway, I think now I made it a little more reasonable. Now when I connect this point and this point, see if I use this ruler. Yeah, I see? Now it's better. Like that. I'm going to connect the first point and the last point. And it needs to be a little bit more steep than the A average 1. And then any 2 points, I can just take any 2 points of this. The slope of that is represented by A average total. Isn't that cool? Looks perfect, huh? This is more steep. This is a little less steep. This is the most steep. And graphically then, we're able to fit V average 1, V average 2, V average total, A average 1, A average 2, A average total. Now on the S graph, you can only show S average. Okay? S average is itself. S average 2 is itself. So 70, 180, and then what's S average total? What was S average total? $60, right? Now, notice here, interestingly, S average total is quite different than V average total. V average total is negative 13.9, which is your effective velocity, remember? That's what we called it. S average total is basically the average height of this function. Well, you got a little hill, then a valley, then you got the sea level or something, ground level. Then you got another higher hill. S average total is the average height here, which is 60. That's your average speed of your whole trip, which is on the whole what the speedometer is showing in the car. Okay? And then the last thing then remaining to graph is the A graphs. The A graph is what is the acceleration doing. Okay, you got 1 hour, you got 2 hours, you got 3 hours. 1, 2, 3. Make this a little. And now, when I'm graphing the A graph, I'm actually graphing the instantaneous acceleration, right? But on top of those instantaneous acceleration graph, I can show what the average accelerations. Okay? Now, I know over here the average acceleration in stage 1 is negative 98. But the instantaneous acceleration is not always negative 98. As a matter of fact, the car, for most of the path, it's not accelerating in the initial path. If you notice here, the velocity graph, what's the instantaneous slope of the velocity graph here? 0, 0, 0, 0, 0. But now over here, as the car decides to stop, then the instantaneous slope is like this. Then the car starts to hit the brake. So the instantaneous slope goes like that, until over here, the instantaneous slope goes like that, again, negative, 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 until the instantaneous slope goes to 0. So when we're graphing the A graph, we're actually graphing the instantaneous slope of the V graph. So for most of the path, it's 0. Then you decide to stop, the acceleration goes down. Then it goes back to 0 at about 5/7 of an hour. So let me extend this more. Then when you're stopping, the acceleration is 0. Then the other one is the instantaneous slope of this one. Over here, you decide to hit the gas pedal, turn direction. So the instantaneous slope, negative, 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 negative again. But this time, it's a lot more negative. So you know what? As a matter of fact, I could erase this because it's going to be so negative. I'm going to go like this. I'm going to put the x-axis way up here. And then this is the way I'm going to do it. I'm going to say, OK, here's 1 hour. Here's 2. Here's 3. It's 0, 0, 0, 0, 0, and then negative, 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 negative. Then back to 0, then 0, 0, 0, 0, 0, 0, a lot more negative, 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 negative. And then most of the other path is 0. Okay? So the instantaneous acceleration is a peak kind of graph. It peaks, then it peaks again. Okay? Its average value here, so the average value of this peak is what? A average 1. The average value of that peak is negative 98. But this, the most maximum, you don't know this value. There's no way to know that unless the problem gives you more information, you see. And then the average value of this one is negative 405. Now, notice it's not to scale. This one should have been, if this is negative 98, this one should have been another 100, another 100, another 100. So this one should have been way down if it was to draw on the scale, but I would have ran out of room. Okay? So that's negative 405. And then the average total acceleration is the whole thing, including the zeros. 0, down, and then 0. So the whole thing is the average height of this, which is a little less, a little more negative, right? So a little bit down. That's average, A average total, which is negative 115. Right? Was it negative 115? A average total, right? So average 1, A average total is more negative. A average 2 is should be way down.